Hello, welcome back. So I'm just going to continue that last little part of lesson 1.2, just in case you needed the review. You should be able to read most of this, but it's okay. So it's just a quick Algebra 1 review on increasing and decreasing functions. And I give you a more formal definition of what that means. So definition, if a function y equals f of x is defined on an interval a, b, and this is just some interval from A to B. It doesn't have to be anything, specific. But an example might be like from -10 to +10, right? Then I say that f of x is increasing on that interval AB if for any 2 points in AB, whenever x1 is less than x2, then f of x1 must be less than f of x2. So, okay, what does that mean? So I started drawing a picture over here. Let me erase this a little bit. So here, I was working on it prior, and I want to start from scratch. Okay, so we said that f is increasing if whenever x1 is less than x2, then f of x1 is less than f of x2. So I'm going to make some little marks. I've grown. What am I talking about? I've established an interval here from A to B, right? That's the interval. I'll do it in red here. From A to B. So I need a x1 smaller than x2. So I had this little tick mark here, and I'm going to call that x1. I'm going to call this x2. And you can clearly see visually that x2 is bigger than x1. It's more, right? Because it's to the right on the x-axis. For it to be increasing, it means that the y value, f of x1, so the corresponding point, right? I might say like y1 equals f of x1, right? I need that point, which might be here, to be smaller than a second point, y2, which is f of x2. So say here's y2 is f of x sub 2. Okay? And then you can see that this point is up here, like so. And so you see if I were to connect this, right? If I connect these two dots to the smooth curve, that is what is meant by increasing, right? It started, as x went to the right, as we increased, the x values, the y values increased. That's really just a fancy way of establishing that idea, that as you go to the right, it goes up. So it's just a kind of a fancier or maybe more formal way of saying that. But do notice that it says for any x1 and x2 within the interval AB. So in fact, you could actually pick, you could pick A and B, right? If I say like x1 is A, so let's do like a point right here. Okay, and we'll call that f of A. And then B, well, it's got to be more, right? It's got to be more than f of A. But really, if it's increasing on the entire interval, it has to work for every choice of x1, which means, look, if I was really close to B, like right here, that f of B would need to be even higher. Okay, so I'll just call some maximum point like right here, and I'll call that f of B. And, I could connect these dots somehow. Maybe it looks like that. Okay? And this is just an example function. This is what it's meant to be increasing. It's just that the smaller, I think you get it. As x goes up, y goes up. What is it meant to be decreasing? Well, keep that idea of reading it to the right. F of x is decreasing on that interval if for any 2 points in AB, whenever x1 is less than x2, so we're still reading to the right, we say that f of x1 is greater than f of x2. So it's kind of a similar situation, right? I'm not even going to really keep this graph, but if I'm in the interval AB, here's x1, here's x2, then I need if it's decreasing, f of x1 needs to be up here, and f of x2 needs to be down here, right? And so that way it's going down, right? As x goes to the right, y goes down, okay? And it needs to work for any choice of two values within that interval, okay? And so that's what's meant by increasing, decreasing. Yeah. And so, I said, in English, please, and all of this is what I just said. So if you want to take a look at this example here, I say, look, observe the graph of g of x on the right here. I say this function is increasing on the intervals negative infinity to 1, inclusive, and 3 to infinity. So take a look at that, right? Let's do it with a little blue, okay? This interval and this interval. So you'll see that as the graph, it's kind of starting over here from negative infinity, right? It's going up. As x increases, y increases, all the way up until right there, right? Right at that point. But then it stops increasing, right? And then it changes to decreasing. And so it's going to be decreasing from 1 to 3. And you can see, oh, it's decreasing. It's going down from 1 to 3 like this, hits here, and then it switches back, right? Then starts increasing again because it's going up. And so we trace along like this. Yeah? And so that's increasing, decreasing, kind of visualized. Yeah. And then some food for thought is g of x increasing or decreasing at x equals 1 and x equals 3, like at that point, right? And if you think about it, both of those points, this guy right here, and then the other one down here, both of those points are the turning points from increasing to decreasing. So, or vice versa, from decreasing to increasing, which means at that moment in time, they're neither, right? At that moment in time, it's neither increasing nor decreasing. It is not changing. Yeah? Okay. And then just some extra questions to think about for homework 1.2. In case you're stuck on that, here's a little bit of homework help. It says, when does g of x equal 0? Well, what does that mean, right? Here, I'm going to erase this. When does g of x equal 0? Remember that g of x is the graph, yeah? G of x is the graph, so I'm going to make this like so. So it's essentially asking, when does the graph cross 0? Or, in other words, when does it meet the x-axis? Well, it meets the x-axis here at the origin, and then here at x equals 3. So if you had to say, use interval notation to answer the following, it's two distinct points. It's really actually not quite an interval, right? It is the number 0, so bracket 0, because it's just that value, unioned with bracket 3. I don't usually see this notation. I probably wouldn't write it like this, but I said to use interval notation, and this is probably how you'd go about doing that. I would usually just say that x equals the set 0 or 3. I think set notation is a little bit better for this one rather than interval notation, because we're not really talking about an interval for when it equals 0. Okay? Yeah. So then let's look at the next one. It says, when is g of x less than or equal to 0? Okay. So I'll put a little red dot here. When is it less than or equal to 0? Well, to be less than 0 means to be below the x-axis, right? This is the x-axis. So if it's equal to 0, it includes those 2 points we were talking about, but it's also below that x-axis. So that means x is less than 0 or equal to or x equals 3. Yeah? That's maybe like inequality notation. So I might say that, okay, that's like from negative infinity to 0 inclusive, unioned with 3. And actually, this is actually something about interval notation. When it's a singular point like this, we don't usually use bracket like that. We actually just call it like a set. So I would actually just say the set 0 unioned with the item. Like it's like an item, right? It's like the interval gives you the interval, but then if it's just one thing in a set, you can union that with it. So the better way to write it would be with those curly brackets if it's a single number. So I'd say from negative infinity to 0 is your interval, unioned with the number 3. Okay? Then the next one. I say, when is g of x greater than or equal to 0? Oops. So I'd look at this, right? And so to be equal to 0 would mean you could still equal these 2 points, but to be greater than would be above the x-axis. So this is above, this is above, this is above, and so forth, right? So it looks like from 0 and onward, we're above the x-axis or equal to 0. So we could just say x is greater than or equals 0, or bracket 0 to infinity is how that would go. And then you might say, okay, what about less than 0 strictly, right? Well, we said that, if you notice, erase again, it's less than 0 in this interval, and then it hits 0 here. But we want to be strictly less than 0, which means we don't want to include that 0. So that would be like x is less than 0. So this would be negative infinity up to 0, but not including 0. And then finally, I'll do purple. When is g of x greater than 0? That means, and it's strictly greater than 0, which means not equal to. So, it's equal to 0 here, it's equal to 0 here, but we don't want to include those points. We just want this interval from 0 to 3, right? 0 to 3. And then we want to skip 3, and we go from 3 onwards to infinity. So this interval would be, so if we did like an inequality notation type thing, we'd say that x is in between 0 and 3, or x is greater than 3. But in interval notation, we would write that as between 0 and 3, not inclusive, unioned with 3 to infinity. And that is how we would define all of those little things. Yeah? Okay. I thought I'd put that video just for help, in case you're stuck on the homework, you don't understand what it means. I hope that explanation gives some light to that. Okay? Alrighty. That's it. That's a pretty short video. Done. Hope it was helpful.